Good day, students. Today we're going to look at a solution to a word problem in trigonometry. It comes from the sample assignment. It's number 13 on page 114. And we have to use right triangle trigonometry to solve. This is book 3, chapter 8 on trigonometry. So it says a conveyor belt is the most efficient if operated at an angle of 31 degrees. If the top of the storage bin is 15 meters above ground level, what is the length of the conveyor belt that goes from ground level to the top of the storage bin, and round your answer to the nearest tenth of a meter? Now, I put in a diagram of a conveyor belt. As you see, a man standing here in front of a conveyor belt putting parcels on it to take it up to another level. But hopefully you can see the right triangle in that, right? Let me just get my pen working here. So, as you can see, the top of the conveyor belt is here, goes down to form a right angle with the distance along from the bottom. Right, so you can see we can use right triangle trigonometry to solve this problem. Now we're going to need the same. I'll draw the triangle over here and I'll put it in. So here's basically what we have, right? And here. So now this part here is the belt itself, right? The slanted part here, the hypotenuse, is the conveyor belt, right? So the conveyor belt here is the hypotenuse, isn't it? Okay, and that's the length we have to find. You can see that is the hypotenuse in the diagram. That's what we got to find. So how do we go about finding that length? Well, let's call it x. Okay, now we know the forms a right angle. We know the conveyor belt in this particular problem starts on the ground and makes an angle of 31 degrees, angle of elevation, which is along the horizontal. So there's the 31 degrees right there. Remember, the angle of elevation is always between the horizontal and the line of sight, right? Now, it also tells us the storage bin is 15.2 meters above ground level. So that means this is the height of the bin over here, 15.2 meters. So all we have to do is find the hypotenuse, isn't it? So what's the length of the conveyor belt so that the conveyor belt is operating most efficiently? Okay, so now we have to choose. Which one are we dealing with? Well, let's have a look. We know our ratios, but let's see. 31, this is opposite. So we're dealing with the opposite side. And x, of course, is the hypotenuse, right? This one is the hypotenuse. So, which trig ratio involves opposite and hypotenuse? Opposite and hypotenuse. Sine. And therefore we do the sine of 31 degrees is equal to the opposite side, which is 15.2, divided by the hypotenuse, which is x. Of course, this is understood to be over 1, so we cross multiply and get x times sine 31 equals 15.2. Now you need to divide each side by the sine of 31 degrees. Okay, so it's 15.2 times the sine of 31 degrees. This cancels, isolating x, and then we end up with x equal to, let's see, bring up our handy little calculator here, 15.2 divided by the sine of 31 degrees. Oops, 31. Enter, and we get 29.5. 29, okay, let me write that down here, 29.5 meters. Well, I forgot to check and see. Let's see, it's the nearest tenth of a meter. Look at the instructions and see how you're asked to round off that number. Tenth of a meter is 1 decimal place, which you already have, right? This means 1 decimal place, tenth. That's what it means. So I've already got it as 1 point or 1 decimal place, right? So our final answer, since it's a word problem, we state it in words. The conveyor belt, alright, should be, because it's asking us what should it be to be optimum at 31 degrees, should be 29.5 meters. So there's the complete solution now for number 13 on page 140.